Thank you very much. I'm Mike Taylor from Hopkins Architects. We're based in London, and I'm going to tell you about this project we finished 1.5 years ago. It's for the charity WWF, who do amazing work in conservation, both of animals and the earth. They had a competition to find an architect, and the ethos of the project had to be, how do you make an architecture which marries their beliefs about the environment? They had no identity in architectural terms. They also wanted this project to be a demonstration to other businesses how you should build an office, how you should work an office, and they wanted to be a trailblazing project, really, to redefine how offices should be. They were based in a factory in Godalming, south of London. It was very dysfunctional. They had no connection between each other, very bad communication, very old-fashioned, very messy, a very unstimulating environment. We spent 3 years trying to find a site with them, but they don't have much money. They're a charity. They do lots of lobbying in Parliament in Westminster, but they couldn't afford to have an office right next to Parliament. So in the end, Woking, which is a town about 50 kilometres outside of London, offered them a site. And the site was this car park here, on the edge of a conservation area, a wood, an area of natural beauty, but by this rather ugly town. But there was a catch. It wasn't so straightforward. The site was a car park, but the catch was that the site had to stay as a car park. Everyone in Woking loves cars and loves their car parks, and this is their favourite car park. So we were allowed to put a building on this site, but we had to keep the car park functioning as a car park afterwards. So here are the woods, a bridge over into the centre of town, and a nice canal here. So a good setting for a building. So we started to think about this, and the concept we came up with was we should make the building like a flying carpet. We should introduce a new world over the car park. And this was the very first sketch, which actually, unlike most projects, was still valid right at the end. So the concept was do some work to the car park, tidy it up, put some columns in the car park, touch the car park as little as possible, put a magic carpet in, and then create some world above that separates out completely from the town, from the cars, and connects you into the forests and the woods around. This is a charity. They don't have a lot of money, so we had to make this very economic. So we reorganized the car park. We couldn't lose any car parking spaces. And we wanted to really make sure that the imagery of the car park and the imagery of their building above were disconnected. We didn't want people thinking it was their car park. We had to keep it feeling separate. And we also had to stop it smelling and have fire and all of these issues about the cars. So this is the world above the car park we created. This is the plan of their office. And what we did on the magic flying carpet was have a green edge to it. And this would provide a buffer to all the cars underneath, but also be an opportunity for them to plant, to grow food, and use the space on the top to cultivate as their own. In the project as well, we rebuilt the bridge across to the canal and organized all the circulation round about. So above this magic carpet, we had the opportunity to create something really special, a lightweight roof that would span across and make their world really, really quite unique. There was another catch here, though. Because they're a charity and don't have much money, they wanted the building to be designed to be institutional, so it had to meet all the requirements of a standard office in case the bank repossessed it and sold it on to a company to use like a normal office. So it had to be radical and yet conventional. So the section we came up with was, these were the gardens on the edge. We could span an arch over the top and use this extra width to bring the arch down and have a two-story building inside with a lot of vision, a lot of connection between all the people, get them talking to each other. They don't work like a normal conventional office. Lots of people are out doing programs, doing missions. Lots of people work part-time. So we did a big study about how they could make all of this space condensed and build the smallest possible building. Clearly it had to be very green. And one of the things we said, if you want a green building, you have to make it as small as possible. LEED, BREEAM doesn't cover this, but it's essential. So we started to model it. We started to look at how this roof could span over the top, and then start to think about how we're going to make this the most amazing in terms of performance. How can this skin adapt and become really sensitive to light, to heat, everything else? So we went through a number of systems, sustainable buildings, and this is a sequence of buildings we've done, and you learn each time. There's no one easy fix to make a building close to zero carbon in use. You have to work away at everything. So we looked at all of these facilities, not just in terms of the use of the building, but also the embodied carbon. WWF had their own criteria in terms of specifications. We really tried to have no PVC and be ethical in every single choice we did. So one thing I'll just point out here that's unusual are these lights, and I'll come on to explain those in a minute. So the way the building works in terms of its performance, it had to respond to weather, British weather, in a very sensitive and reactive way. So coming off the back of projects we've done with the same engineers at Yale, we devised the building to work in two modes to get it to be the most efficient. It had a natural ventilation mode for spring and autumn, so a day like today, say. And in that mode, what we would do is run it like your house. You would open the windows, you would naturally ventilate the building. If it got a bit warm, you could take air out of the top and disperse that. You would be shading sunlight coming in. It'd be well insulated, and you'd be comfortable. You basically shut down the mechanical systems. However, in the summer, when it's very hot and maybe humid, or in the winter when it's very cold, we were going to shut down the external skin of the building, and we would bring air through the floor voids, cool air in the summer, warm air in the winter, from the systems I'll explain in a minute. The top of the building would be shut down. In the summer, you could exhaust a bit of air out of the top, but we would more likely recirculate it back round into the system, so we're not wasting energy. We were trying to run this whole office for 300 people on about the same amount of energy as 2 houses, so really minimal. And you can see here all the servicing is happening in the floor above the car park, which is totally autonomous. The lights I pointed to indicate to the staff if it's going to be a natural ventilation day or a mechanical ventilation day. And so they would be get messages on their computers and have to work with that system. So you can't have one person opening the window when it needs to be mechanically ventilated. So before we put the car park in, we went into the ground and did some things in the ground to make the building more energy efficient. So we buried 6 1.5 meter diameter ducts underneath the car park, and these are like the lungs of the building. So before the air in mechanical mode goes into the air handling equipment and comes up through the floor, it goes through these tubes in the floor. The benefit of this is the ground is at 12 degrees centigrade. So if you're trying to warm the air in the winter or cool it in the summer, you're getting free preheat or pre-cooling, because if it's 30 degrees outside, you pass it through those ducts, it's going to come down from, say, 30 to 18 degrees or so. So this graph explains that. The red is the fluctuations in daily external temperature, and the blue is the temperature of the air coming out of the pipes. So once you put those in the ground, made them waterproof and paid for them, you've got a very good means of cooling and heating your building. In addition to that, I should just say here, this is where the air comes in and goes underneath. In addition to that, for the very hot weather, we had 100-meter ground source heat pumps in closed loops, 20 of those underneath the building, and those could just provide some very cool water from deep down in the aquifer to chill the air handling units. So all very, very efficient. These are the closed loops going in. This is the head of them, where they come up. This is the drilling for them. And we also collected all the rainwater. We recycle that in the toilets. We use it for irrigation. And on the magic carpet, we collected the rainwater off the roof and attenuated it through these tanks and used that as a filtration system. And then we had a SUD system which collects the rainwater before it went into the canal. So here are the tanks going in. So we put all these 3 things down, rebuilt the car park on top. Here's the car park. They cast the concrete above. The concrete had very high recycled steel content. We used recycled aggregate, everything we could to make the building environmentally sensitive. And then in the world above that slab is WWF's new office. And here you can see the floor going in. There is a short video on Vimeo if you're interested in the construction. I won't show it now. So when we won this project, we said, look, we can't just design a building. We have to really think about everything, from the number of people, the way you use the desks, the size of the building, the furniture, everything. So we worked literally at every single scale of the project to marry it up to what they do. The space they have is about 10 square meters per person, which is a standard for a British commercial office. But we only give about 60% of the people a desk. Because of the way they work, it's much more fluid. So we spent a long time working out how many desks we needed and how many flexible spaces. Here you can see the kind of studies we did with the furniture, all of which was sourced to be FSC certifiable. So this is the ground floor. Ooh, sorry. You come in here, there's a kind of museum and exhibit with a children's schoolroom, a boardroom, a reception area, and then the main workspace at the back. Kitchens and cafes at the back and ways out onto the terraces. And a central street in the middle with lots of different types of breakout space, including on the outside, different types of furniture for different uses. So here you are in the middle of the space. You're standing on the lower of 2 floors. And the way we devised the section really was that everybody could see everybody else. No one has a fixed place. Everyone moves around, including the chief executive. And I'll talk a bit more about that in a minute. What you're looking at on the ceiling are loudspeakers, and in the background they play bird song as the white noise, just to make an ambience that's commensurate with everything they're doing. And here you see some of the breakout spaces. Here's the cafe in the background, here's some spaces, and on the edge as well, little breakout spaces, and then much more regular desks down the middle. If you then go up to the floor above on the mezzanine level, there's a conference center here. They rent that out. It makes some money for them. They can use this. It's flat floor, so they can use it for special events, or they can have lectures in there. More workstations, and then offices you can go and use for special meetings, interviews, etc. And then looking down over the back. So when you go up to the upper level, this is the view. We brought the trees inside, and we managed to very cleverly kind of move the windows around the building. So you're never looking at the ugly town. You're always looking out at the nice green trees. So you feel pretty much like you're in the Amazon when you're inside there, which is nice. Here's the loudspeakers. Here's the desks. And then as you look across the space, you're always looking across to colleagues. And since they've moved in, the productivity and kind of staff absenteeism from illness and everything has really, really improved. I mean, the social cohesion of all being in one space, all sharing this kind of routine of coming in and finding a different desk each day, has massively sort of re-engaged their staff in their mission. And they're very, very happy with the building and have been working in there for a year and a half. This is at the entrance, so looking down onto an exhibition space that they've put in themselves. This is the lecture theatre and the breakout for the conference and the sort of small meeting rooms at the edge. I'll come on to these details in a minute. Here's the lecture theatre. These blinds go up and view through. The roof lights open. So, I mean, if you're working for a charity, they've been given some money to build this building, but they were very anxious that people didn't think that their donations, like my mother-in-law who gives £3 a month, was going to go to pay for the building if you're trying to save a species. So they had to spend the money they had, which was not a lot, but we also had to work with very basic materials. So we have very agricultural kind of quality detailing here, deliberately very simple. These are just really quite crude galvanized plates with steel pins driven through them. There's not even complex geometry. We just lived with these intolerances at the top. And then the twisting, we just welded into the plates. The holes are for services to go through. This is all FSC certified timber. And here you see the grid shell going up with the CLT sections on the top that make it rigid. Here's the bridge going in across the canal. Here's the ugly town. And one of the key things we had with this roof was a chance to bring light in an unusual way. And so we really wanted to reduce the amount that people were working under artificial light. So we did lots of studies looking at the shading from the trees and balancing heat gain, solar gain, and glare against comfort inside. So we managed to get very good levels of daylight all through the building on both floors. I mean, obviously a bit less under here, but we've got artificial lighting. And we did some interesting things, like we didn't necessarily have windows right opposite the edge of the mezzanine level here, because we realized that you could have good light down from the top and you could see across and always see out to greenery from everywhere. And on the end walls, which we wanted to be open, we studied the sections to make sure that the sunlight didn't come in too much on the ends, but gave you these fantastic views out. Here you see just really basic materials. We didn't even pay for a finish up here. This is the box for the bats, the pipistrelle. And then on the roof, we had the opportunity to put about a 100 kilowatt array for PVs. You know, the trees were shading that a little bit, but we balanced the PVs and the glazing to let light in. And one of the issues we've had over the years, when you build a big, heavy building out of concrete, stone, or concrete and masonry, you've got thermal mass, which is very good for balancing temperatures throughout the day and across warmer weeks in the summer. However, when you've got a lightweight roof, you don't have the thermal mass. And it's always been a challenge. In this project, we actually used a phase change material. These panels, which have liquid paraffin in them, and they change state between solid and liquid at critical temperatures. So they mimic the behavior of thermal mass. So in this ceiling, we have these panels, which help balance out and make it perform a little bit like having concrete overhead. On the top, the wind cowls need to be very sensitive to work at low wind speeds, so we built them on aluminium, very, very lightweight, on a fairing so they rotated around. They arrived in, went on top of the building, and you see them just moving around in the wind. And then the air goes up through those, through the vents in the ceiling. Obviously, they're closed off in the winter, and acoustically and thermally insulated. So the ceiling, I should just say, it's just very simple birch-faced ply, just screwed in, that you could buy in any shop down the road. Everything very simple. And then, in terms of the behavior of everyone in the office, it was unconventional to have this open plan arrangement where you didn't have your own desk. When you go and visit them, they all have pictures of their family and their football team, all of those things on their desk. But every night, every single night, they tidy it all away, and they all have a locker and a basket and put everything in the basket, in the locker, and they have a policy that works perfectly. If you go in the evening, it looks absolutely pristine. So this is it in the day, underneath one of the mezzanines where everyone's got their desks, all with their stuff on the desks. And then you go in the evening or at the weekend, completely clear. So all the architects that visit this thing, it's an absolute fantasy. They tidy their desks every night. And they all have laptops, and the whole thing works on a very clever IT system that we help them design so you can move anywhere and do anything in the building. And one of the other things about this project that made it unusual, because most of these technologies exist, it's just a question of how you bring them together. We did, with Simon Sturgis, we did an audit of the carbon on the project. Now, carbon is something it's hard to know about. It's like a whole economy, but it's invisible. And so every single thing we did on the project, every material we specified, every lorry, every truck, the lights in the site huts, everything was recorded. And when the contractor was trying to change one window for another window or change the concrete, everything had to have a financial value and a carbon value. So we could track the carbon use in the project. And so we could work out how much carbon we saved against a normal sustainable building. And so this was his model where he literally tagged carbon to all of these elements. And it threw up some things that were counterintuitive and you wouldn't expect. So at one point in the project, we were struggling to pay for triple glazing. And we knew that triple glazing would perform slightly better. When we ran the carbon analysis, we actually found out that double glazing had a better carbon story. It had less weight in the frames, less carbon in the actual glazed units. And over the life of the building, a double glazed unit would use less carbon than a triple glazed unit. So on projects like this, you can start to learn the sensitivity of these things, but only by commissioning someone to follow it. So we had about, from stage C, which is like a progetto di massima, we had about a 40% reduction in carbon just by knowing what we were specifying compared to a standard project to completion. So we also found that when you look for furniture and you try and find FSC certified furniture and you're absolutely rigorous about applying that, most people don't have the full chain of custody, can't tell you where everything's from. And actually the industry really needs projects like this to push it, to be more aggressive in terms of knowing about chain of custody. So we managed to do a whole series of performance targets that make the building quite respectable in terms of how it behaves. It's not entirely carbon neutral. I think it's very difficult to get that when you factor in all the loads from the plugs and everything else. And here you see the final building looking like Noah's Ark in the Amazon floating away. And then I think the challenge for us was to make this very special place inside with all of these sustainable criteria, have the car park underneath but disassociate it with the car park and make it all work. And I think actually what was most radical about this building was this aspect, which is a sort of a parasite building. It's a building that doesn't even have its own site. It could go anywhere. So it's not even a brownfield site building. It's an air rights building. And it was opened by David Attenborough, who had these kind words to say about it. So thank you very much.